Alright, this is Roger, Mud Fossil University, double slit experiment. I want you to try to explain
How
this.
many?
It's one circle.
Well, there's one in the middle strongest, two either side.
The two on the outside are multicolored, and the one in the middle is just white.
It's kind of a rainbow?
The rainbow of colour as well.
Quite a few colours with lots of little dots.
Like there are more dots appearing.
I think I can even see more dots spreading along. Yeah, that's amazing. Yeah, I can see tons of dots now. Not tons, but I can see dots spreading across that way.
Either side.
Yeah, definitely.
Isn't that amazing?
Yeah, that's...
Okay, that's all we need to see. This guy is fabulous. Veritasium. I highly recommend his videos. Now, I saw this 4 or 5 years ago, and I'm thinking, wow, this is amazing. And then I lost track of it. I could never find it again. I couldn't remember how he did this. But these colors, I think I understand why they're separating out in these ways. Maybe. And I believe it has to do with the distance from the slit to the back. Maybe. Now, Rod Warren did the same sort of thing, only he can show that it's spinning light. And that's what I have always said, light is a spinning particle going forward. And he captured it in a number of ways. What you're seeing here is different than the normal double slit experiment because Rodney is using nails, which is a Venturi, which means it'll hit and it won't just cut along the side, it'll roll off the side. That's why we're seeing these trails come as they roll off the side of the nails. Additionally to that, he's got them to where they're like two airplane wings facing each other, and the light is constricted in that gap and forced into what's called a Venturi, and it has no option whatsoever other than to crush itself together, create an unbelievable amount of energy, and then accelerate. There's no other option. Zero option. This is why I can say that light accelerates. This is a standard wave not being accelerated. This is that same disk approaching the accelerator Venturi, which compresses the light particles and forces them to become involved in each other's regions, and they become extremely explosive. Once they step away from the accelerator, they reconstitute back into their own separate particles and stream off in charged particle carriers. These tiny white fibers are coming at us. They are the charged particle carriers. They're highly accelerated in Cherenkov radiation. They create a Higgs field that surrounds the charged particle once it collapses itself as a result of compression into the ether that is creating these little dots and fields as a presentation from the crushing impact of that charged particle blossoming out a field surrounding it. It's called a Higgs field. Cherenkov, high energy electronic radiation. Higgs, boson particle, charged particle carriers, Higgs fields. The particle is in the center, will never be seen. I say it will never be seen. It may be seen. This may be the particle. That's the acceleration Venturi. This is stepping down. It presents these particles occasionally, and then it steps down. Or Rod's captured them occasionally. I've only seen this twice. Alright, listen one more time, and then see if you can figure out what's going on, and try to make some comments on what you think is happening.
But all we're doing is we're putting a light through two very narrow slits, side by side. So how does this make any sense?
There's some kind of principle involved there.
Alright, there is a principle involved. See if you can figure it out, because I'm having a hard time. Okay, second mystery is the Rattleback. Watch what happens to a Rattleback, and then you have to try to figure out why. Watch what happens. It turns around and goes backwards. Why would that happen? Alright, now watch what else happens. It goes the other direction and never stops. And it doesn't go backwards, let me put it that way. Now he does this. Why would it do that? Alright, these are your mysteries. Okay, so go to Mud Fossil University And tell your friends to go there, because you have a blast up there. You should have parties. I'm telling you, you have parties. Everybody comes over. You watch these things. Oh, you have a blast. I'm telling you right now. You can watch all night long. Somebody's going to find something they like. All right? Mud Fossil University on YouTube. See if you can figure out these things. Tell me what you think's going on. I'm going to do a video on this. I think I know what's going on about that. But you're never going to get it unless you understand ether. All right? Mud Fossil University, have a sterling afternoon. Comments about this stuff would be fabulous. Thank you.